Hey everybody, welcome back to my channel. In this video, we're going to discuss how to figure out the empirical and molecular formulas when you are given percent composition data. Right, so this first question that we're going to work through is very straightforward, and then the next one's going to be a little more difficult. So the first step in any of these questions that you work is if you are given percent, convert it to grams. This is the easiest thing you have ever done in chemistry because all we're going to do, all we're going to do is pretend like it was given to us in grams instead of percent. And we can do this by just assuming 100 grams of sample. So then they'd be the same. All right. The next thing you're going to do is to go from grams to moles. So you're going to divide each by its molar mass. So I have carbon, hydrogen, and oxygen. So I'm going to do that 3 times. So for carbon, 52.14 divided by its molar mass of 12.01. The 13.13 of hydrogen divided by 1.008. And 34.73 divided by 16.00 for oxygen. Again, I'm just pulling those numbers off the periodic table. Okay, so the numbers that we get here are 4.34 moles, 13.03 moles. I think I just said 4.34 moles, excuse me, 13.03 moles of hydrogen and 2.17 moles of oxygen. Now, we are going to find the smallest of those 3 numbers, which in this case is my 2.17, and we are going to divide all 3 numbers by that. Let me write that down. So divided by 2.17, divided by 2.17, divided by 2.17. And I get 2, 6, and 1. So if your answers are whole numbers, then they are the subscripts of your empirical formula. So because these are all whole numbers, I literally am just going to write the element and then that's the subscript. That is the empirical formula, C2H6O. Now the next piece is to figure out the molecular formula. So the empirical formula by definition is the smallest whole number ratio of element to element. I can't reduce those numbers down anymore. Molecular formula is not necessarily like that. So we're going to figure it out. So if you do not have the molar mass of your molecular formula, you cannot do this next piece of math. Okay? So I'm going to give you this formula. You're going to take the molecular formula, molar mass, and you're going to divide it by the molar mass of that empirical formula that you just got. And this is going to give you your multiplier, which you're going to multiply times the subscripts in your empirical formula. Right? So we have 92.1, which I was given. If you're not comfortable calculating molar mass, please go back and watch my video, which I will link here in the cards, and then come back. So I'm going to skip that part. I'm just going to tell you that the molar mass of this empirical formula is 46.08. So when I divide, I get 2. What that means is 2 times all of my elements for my empirical formula, gives me my molecular formula. So my molecular formula is carbon, 2 times 2 is 4. Hydrogen, 6 times 2 is 12. And then oxygen, 1 times 2 is 2. Okay, so like I said, that is the straightforward version. Now we're going to get a little more complex. So let's follow along. And I'm just going to bring my little steps down here, but I'm actually going to make some space because we're going to have to add a little something in here. All right, so here I've got carbon, hydrogen, and fluorine instead of oxygen. So I'm going to do the same thing. I'm going to make sure that they are all in grams by pretending that they were just given to us in grams. Then I'm going to convert them to moles by dividing by their molar mass. And the new player to the game here is fluorine. Its molar mass is 19. Right, so I get 4.791 moles, 3.423 moles, and 2.053. All right, so that's step 2. Step number 3, I'm going to divide all 3 of those numbers by the smallest of them. So 2, 3, or 4, 2 is the smallest, so we're going to divide everything by that. And I get 2.33, 1.67, and 1. Okay, step number 4. If these are whole numbers, well, they're not. 2 of them are not, in fact. So, not whole numbers. So what we have to do here is we have to use our knowledge of fractions to identify what that fraction is. So 0.33 is 1/3. 0.67 is 2/3. If you are not comfortable with that, what I would suggest doing is going back through and re-familiarizing yourself with fractions, let's say up through the fifths. So you ought to be able to recognize by sight what 1/4 is, or what 2/5 is, or 1/3 or 1/2. You ought to be able to recognize those. Okay, so once we figure out what the fraction is, we're going to multiply them all by the denominator of that fraction. So because these are both thirds, we're going to multiply every number by 3. So times 3, times 3, and times 3. So what I end up with is carbon is, excuse me, carbon is 7. And hydrogen is 5, and fluorine is 3. Now I have whole numbers. Now those are my subscripts for my empirical formula. All right, and then just like in the previous problem, once I find that, I need to figure out what my multiplier is so that I can find my molecular formula. So I'm going to calculate the molar mass of C7H5F3. And the molar mass of that is 146.11. We do 146.11 divided by 146.11. That That gives me a multiplier of 1, which means that my subscripts don't change and my empirical formula and my molecular formula are the same. You can either do this math or you can just recognize that those two are the same, so the formula has to be the same. And that's how you do the empirical molecular formula when you are given percent composition data.